Firstly, before we jump into this, again, I'd like to acknowledge that all of the work that I'm talking about today and what I'm hoping to achieve over the next few years as part of this broader project is taking place on Gadabanud country. So I'd like to pay my respects to elders past, present and future as well. Now, it's quite a large story. It's got its ups and its downs, but I guess one of the fortunate things about making this presentation go online is I've been able to open it up to both friends and family as well. So for the uninitiated, you probably heard me talking about Potoroo this and Potoroo that. Just briefly, they're actually a small kangaroo. So if you look at those feet, they share an ancestor, more closely with something like your classic eastern grey kangaroo rather than a possum or any other marsupial around. They're actually a small kangaroo. And what they love to do is they love to bounce around their little environments and dig up underground fruiting bodies of fungi. So they've got those claws that help them do so. And by doing so, they're turning over the country, great implications for a bunch of different vegetation around there and helping to spread that mushroom as well. But unfortunately, they're also struggling. So they're a species, particularly at that size, that's particularly susceptible to habitat loss, predation from invasive predators, pretty much everything we've done since European settlement 200 years ago. So they're not doing so well. They're a species in need. And just for reference here, your garden variety Potoroo comes in a few different sizes. This is a bush rat for scale, but they can be quite small. They can get a little bigger and they can end up quite chunky. So they are in the area that we're working in, they're getting in at around 800, 900 grams or so at an adult weight. And we know they love the Carwell Heath. So the Carwell Heath up the back of the Otways there, it's certainly much drier than the vegetation we've been working with over the past few years as part of the Otway Arc program. We're moving into what we call Heathy woodland communities. As Jack mentioned, it's a diverse mammal community, so they really seem to be doing quite well up there. And it's a landscape that's really dominated by the presence of the austral grass tree or the Xanthorrhea australis. It's great shelter habitat for a lot of these animals as they get older. The skirts of those grass trees end up making quite nice little shelters for these species to hide in during the day. And one of the tricky things about the grass tree community is that it's incredibly flammable. So this is a picture that we've taken of a fire in Heathland community, and it just gives you a bit of an idea of how, I guess, flammable this sort of country is and how challenging it may be to manage in the context of fire. And it also presents a bit of a risk to communities as well. So I just wanted to highlight this. What we're looking at there is some post-fire mapping of a lightning strike driven fire at the start of 2020 that really made quite a quick dash over towards the Gellibrand community over there in the east within the course of a day or two. So it does present a risk to communities, but it's also a landscape that needs fire as well. So this very same fire that presented a risk to the community of Gellibrand actually resulted in a mass flowering event of these Xanthorrheas, replenishing the seed bank. So we know it's a country that needs fire. We just have to figure out, I guess, how best to appropriately do that. And just to add another layer of complexity on top of things, this is where it gets a little tricky, is that we also know there's this mounting evidence that invasive predators seem to really like post-burn environments. And it's not hard to see why. It's a much more simplified sort of structural community. It's a lot easier to move around in. And it certainly seems as if they have quite good success hunting in these recently burnt areas. And so they certainly seem to prefer to exploit them. And this really does arise a bunch of questions. We're really starting to scratch the surface here in terms of understanding that mechanism. So, we don't really know how long this really intensive use of burnt areas occurs for. We don't know from how far away animals are being drawn in from the landscape to use burnt areas. We also don't know if all individuals respond to fire sort of consistently. So, we don't know if there are some animals out there that simply love burnt environments and others that could take it or leave it. And we really don't know intimately what, I guess, the impacts on native species are. We certainly can assume that they're going to be negative, but the degree to which it is negative, still debatable. And I guess we want to be asking all of these questions because if we can answer them and if we can understand why predators respond to fire, then perhaps we can simply devise a way to mitigate this and try and get on top of it to take it away from being such a negative impact, which unfortunately we're about to see. But really, I mean, the simple question that I'm going to talk about today is how fire in the Carlisle is affecting Potoroos at the moment. So simply a small subset of that overall broader question we're interested in. Now, we're going to go at this in a slightly different way. Often we use camera traps to try and answer some of these questions. We've gone down the route of actually using GPS collars, and for good reason, which I'll get into in a second. But first of all, you know, there's a bunch of pros that comes with using GPS technology to address this sort of question. One of the biggest pros here is that we're following individuals and we're collecting a lot of information about them. In effect, every hour, we're going to know where that Potoroo was. And ideally, we can do this both before, during, and after the fire event itself. There are some cons, however. GPS collars are certainly towards the upper limit of expensive operations. So each collar really quite expensive. Battery life's quite constraining as well. In effect, which we'll see, we can only really get 6 weeks worth of information. And they are quite labor intensive as well. So we've got to get out there. We have to catch the animals, attach the GPS collar to them, monitor them pretty frequently during collar deployments, and then get out there and recapture them to collect that collar before we even can even work with that data. So pretty labor intensive. Fortunately, with that support from the Hermon Slade Foundation, we're able to get a project up and running. Now, when it comes to this study, it's reasonably simple. It is all about timing. So we really want to know where Potoroos are every hour over 6 weeks. Okay, so that battery life gets us about 6 weeks of knowing where these animals are. And ideally, there's a fire somewhere in the middle of that. And what we're looking for is effectively post-fire changes in things like survival, which areas they're using and how large an area that is, what habitat they're selecting for, and how they're moving around in the landscape. Now, we've done this over the last 2 years. COVID made last year's forum, pretty hard to pull off. So we put it off to this year. That's why I was so excited to talk about it. We have 2 years worth of data to talk about. And all of the Potoroos from 2020 are pretty much going to be named after Grease characters. I'm fairly sure my partner and I had just watched the movie and I thought, why not? Let's start with the Sandian and Danny and go from there. And in 2020, we were able to attach GPS collars to 7 individual Potoroos where no fire occurred whatsoever. And one of the reasons we wanted to do this was to just get a bit of a baseline as to what is normal for Potoroos in absence of fire completely. So what are they doing? How are they using that landscape? What does mortality look like during a 6-week period? And then we were able to attach GPS collars to an additional 6 individuals that were exposed to 2 different fire events, which I'll get into in a second. So that's 2020. During 2021, this year, we decided to go with Harry Potter names, the Potteroo Chronicles, and we're really able to ramp up our focus on what happens after fire. So we were able to collar 7 individuals in the first burn and 6 individuals in the second burn for the year, who are all named after Harry Potter characters. So some familiar names in there. And just a quick note, we weren't able to work with any females with pouch young. This is an ethical constraint. We didn't want to sort of put any females or those pouch young at risk of ejection by, holding them down and attaching collars. So they have not been included. And before we jump into all of the data, all of the results, I simply have to acknowledge that although I'm the one presenting the data today, this is a massive group effort. We've really been throwing ourselves into this. So you see interns, staff, resources to get this job done. And I'm really proud of the work we've done so far. So I hope you'll enjoy the ride. Just really quickly, because our interest is on how Potoroos respond to fire, I won't talk too much about the Potoroos that simply weren't exposed to fire, our little baseline population, but very quickly, they had fairly large home ranges, a bit larger than we expected, between about 3 and 23 hectares or so. They were active throughout both the day and the night, which is a little bit of a surprise. Primarily, we thought they would be mostly nocturnal. Turns out they move around a bit during the day. Very little evidence of territoriality, so they're effectively living on top of each other. And there was this real reluctance to move across any roads or tracks. Often, when these features were in the landscape, they would form a bit of a hard barrier as to where these animals would put their home range up against. So let's start to jump into some of the burns. The first burn I'll talk about today is easily the largest one. This is Jellybrand Valley Road. It's about 280 hectares or so. And there was this beautiful patch of long unburnt heathy woodland on this slope here, where we were able to get out there and attach GPS collars. And since they were our first 2 animals, a boy and a girl, we thought we'd call them Sandy and Danny. Now, just as a bit of a visual demonstration as to how this country can change after fire, we have unburnt on the left and burnt on the right. You can simply see that structure, that vegetation has been simplified dramatically. So let's see what happens. This is just our area again, showing that it was certainly exposed to fire. Red areas mean high fire severity. Now, just really quickly, see that shape up on up the left there, that blue little shape? That's Danny's pre-fire home range. So this is the area that he was using before the fire was in the landscape. And the red points are the movement data after the fire was put in. So we can sort of see where he was and also where he went after the fire. In effect, he tried to make a bit of a go of it, living in his pre-fire home range until eventually abandoning it and moving across the road. Unfortunately, after 9 days, his collar was found in mortality. Very likely, he was predated upon shortly after moving across the road. This is completely different vegetation that he'd moved into as well. Not the Heathy woodland community anymore. This is a bit more of a shrubby foothill system. Now with Sandy, again, same deal. We can see where she used to live. Same situation, same response, real strong association to that pre-fire home range until eventually she too abandoned it and moved across the road and suffered a similar fate as Danny after about 2 weeks, so 14 days post-fire. The second burn for 2020, we were able to get 4 individual Potoroos collared in this one. It's a much smaller area, so we're looking at about 35 hectares or so. And we can see these 4 animals and their pre-fire movement points and ranges here. Just really quickly with Mr. Eugene, I'm not sure if you can see off to the right, the blue one, a great example of how an animal may actually straddle its home range across a gully system, use it to move across, but certainly not seem to spend a lot of time in there. That was quite an interesting find. This fire was actually a bit patchier as well. So we went out there with GPSs and I was pretty lenient. I actually, we went around and included any vegetation patch that was larger than about 1 square metre in the hopes that this could act as unburnt refuge here. Let's see what happened. After 2 days, Vince here was found in mortality. So very, very quickly, you can see his post-fire movement points fall squarely within where he was before the fire as well. And he did not live very long, unfortunately. Marty, similar situation, an additional day had passed, but she too suffered the same fate as Vince. On that same night, Eugene here, who only had half of his pre-fire home range burnt, also succumbed to predation. And after 5 days, Blanche over on the west, she too was found in mortality. So that's 4 animals within the space of about a week or so. Again, surviving that initial fire event and being found predated upon shortly afterwards. So that's a bit of a yikes. Of those 6 Potoroos that were exposed to fire, they all died within 2 weeks of the burn. And there seemed to be this really strong fidelity to their pre-fire home ranges, whether or not they burnt. But of course, some pretty large caveats here. We're talking only about 6 animals. So small sample sizes, lots of what ifs. We really don't know if this is a consistent and representative outcome. That's why we wanted to repeat it this year. Now, in 2021, we were able to focus primarily on 2 burn blocks here, ranging from about 100 to 130 hectares. And with these burns, although they were sort of, using the road network, we were also using natural fuel moisture differences to bound the burn. We could be reasonably confident that under the conditions we were burning, these fires would not escape to sort of the east or to the west. They're running into gullies where you could be pretty comfortable they're not going to burn. And for the 2021 Potoroos, we've got a nice little advantage here, a little addition to our data collection in the fact that we're now collecting accelerometer data as well, so activity data. And one of the data streams here is temperature. So this collar sits right at the animal's neck and it's collecting temperature as well. And so we can use this as a bit of a proxy. So what we can see is that when there was high temperatures, they were generally associated with periods of low activity. It kind of makes sense. These are when the animals are sitting there bunkered down in their grass tree skirts, sleeping away the night. It actually seems quite warm there once they stop. And the lower temperatures were generally associated with periods of high activity. So when they're running around, moving in the landscape, that is actually a mum and a young at foot, that little blur behind her there. But I guess the best thing about this temperature and why it's so useful in the context of seeing what happens after fire is we can look for very large step changes. What we can see is that to the left of that little red oval there, that's normal, oscillates up and down, periods of activity and inactivity, until all of a sudden we can see that temperature drops remarkably and never gets back to what it was beforehand. What this allows us to do is actually to narrow in on when we think that animal may have last been alive and effectively get to plus or minus an hour or two of when we think that mortality or predation event occurred. You feel a little bit like a detective. So what happened in the 2 burns this year? Well, first of all, we'll focus on a bit of a smaller burn. So this one was only 10 hectares, and we had 6 animals collared in this area. This is their pre-fire movement data, pretty good coverage. We can see again from that pre-fire home range estimation that they were effectively living on top of each other. This is 5 males and 1 female. So again, little evidence of territoriality. And the burn itself was quite small. It was reasonably contiguous. So where it burnt consistently, but it wasn't exactly a large area, only about 10 hectares or so. And given that we have that extra information, rather than go through and follow each individual through time, I figured this time we might actually just sit back and watch what happens to that community as a whole. So what we're seeing here is the pre-fire movement data of all of our Potoroos at this block, and then the fire was put inside the landscape. Now remember, last year we saw that all Potoroos had died, that were exposed to fire had died within about 14 days. And we're getting up to a week, we're getting up to a fortnight. This is great. We were out there, we're listening for these animals. They still seem to be alive. They still seem to be using the burn area, running along across. We get to about 4 weeks post-fire, and then we start to see 2 mortality events, both Dumbledore and Sirius dying within a relatively shorter period of time from each other. Mad-Eye Moody is knocked off 32 days after the fire shortly, and then unfortunately Creature as well is knocked off about 39 days after the fire. The other 2 animals there, Snape and Ginny, they survived, which is wonderful, but that still leaves us with about 2 of 6 animals surviving. And we have a little bit more context to work with this burn as well. There's some pretty strong evidence that a fox was responsible for at least 2 of these predation events from this burn. We found Dumbledore caged. Now, what that means is that this animal was effectively predated upon and then buried, saved for later. It's a really characteristic fox behavior. And remarkably, it seems as if we may have actually captured a predation event on some cameras that we had in the area as well. We actually think this is probably Mad-Eye Moody, one of the animals who died from this burn in the fox's jaw at this moment. He was last known alive at 11 p.m, very nearby, and this camera image was taken half an hour later. So I guess when we finish that burn, we end up with about 2 of 6 animals surviving, but importantly, they didn't die immediately, which is what we saw last year. So they survived upwards of about 1 month post-fire, and then they started to fall off. What this means is that we do fortunately have some pretty strong pre and post movement data to work with now. For our last burn, this is your classic Harry Potter setup. We've got Harry, we've got Luna, we've got Neville, we've got all the classics here, and we've got pretty good coverage right across the burn area. This was a burn of about 38 hectares. Now, again, this is their pre-fire home ranges, so they're occurring fairly reasonably consistently right across the block. And this burn itself was a little bit patchier as well. So let's see what happens. Again, we get our pre-fire movement data, we catch animals, we attach collar, they come online and they move around the landscape. And so what I want you to do is watch what happens immediately after the fire comes in. Here we go. The very first night after the fire comes in, poor Neville is picked off down the bottom there. And shortly after, at about 6 days after fire, Hermione up the top also pays the price on the edge. Luna, about 14 weeks, Luna Lovegood, 14 days after the fire or so, is picked off to the west. And for the next fortnight or so, life goes on. If you have a look at Voldemort up the very top, the blue one, he's still eking out an existence, even though most of his pre-fire range was burnt. Dobby dies at about 30 days after fire. We collect Ron and Harry's collars, we catch them back, they survived. Voldemort didn't want to go into the trap during this period and unfortunately was found predated upon at about 38 days post-fire. So Harry and Ron survived, which is great. And what we can see here is sort of their pre-fire ranges, those shapes, alongside their post-fire movement data, those points. And you can see by and large, they effectively kept to the same areas. And so for this burn, we end up with 2 of 7 of Potoroos having survived. And importantly, that these ones, they didn't all die 1 month after fire, and they didn't all die immediately after the fire. They died intermittently over 5 weeks, about a Potoroo a week. So we're really seeing that broad spectrum in how fire can affect the community. And we didn't have any evidence of caching, so we didn't find any Potoroos dug underground, which would really point towards foxes, but there certainly was evidence of foxes in the area. So I guess we can sort of zoom out a little bit now and start to look at, I guess, some consistent outcomes from what we've seen from the research so far, if we sort of sum up all that Potoroo data we've collected. And there's a few key points that I'd like to talk about really quick. So far, few of the Potoroos we've been monitoring have survived 6+ weeks post-fire. That's pretty grim. And like I was just saying, it doesn't seem to happen all at once. It can happen quickly after fire. It can happen, death by 1,000 cuts, or it can all happen quickly, but 1 month or 1.5 months after fire. These are the results we've seen so far. And there really does seem to be this consistent reluctance to move from their pre-fire ranges, regardless of how much of it burnt. And there's a couple of good examples here. What I think is worth paying attention here is the similarity in these shapes. So what we're seeing with the hard shapes, the hard boundaries, the solid lines, that's their post-fire home range areas, and the dotted lines are their pre-fire home range areas. So you can see, regardless of how much of it burnt, they were using the same areas. And what this means, unfortunately, is that that period of heightened vulnerability after fire, it may actually be a bit longer than we would have hoped for. I was kind of hoping that, what we saw last year may just be a case of all the animals dying quickly and not having enough time to shift their home range areas into unburnt country away from the fire. What this effectively means is it's a bit of a bummer. So it's a little bit more of a complicated situation to manage. Many of the predation events during all of these burns appear to have happened at or near the burn boundary as well. If we have a bit of a look at where these animals were last known alive, you can see that by and large, most of them occur within a pretty good proximity of the burn area. Not always within the burn, but certainly nearby. And I guess an important note here is that survival isn't guaranteed beyond the end of this data collection that we've been doing. There's a couple of good examples here. We can see Harry and Dobby, both pretty much occurring within the same area post-fire. However, Dobby did not survive and Harry did. And remarkably with Snape here, Snape is the yellow area there. He had a home range that effectively overlapped both Creature and Dumbledore. They didn't survive the fire, yet he did. There's potentially a whole range of reasons why this is, but I guess the important point here is that just because they survived our collaring study doesn't mean that they're any less likely to, or any more likely to survive for the next year, 3 years, 5 years, etc. If we zoom out even further, we have to think about the end game for how we want to work in this country and how we want to manage it for both fire and biodiversity values. And again, back to that point we made at the start, not burning this country at all simply isn't an option. There's a chance that if we do that, if we really step back, then as Jack mentioned, lightning strikes, a big wildfire could simply come through and wipe out this whole area all at once. It also presents risk to communities. So not burning isn't an option. And I also think it's important to note that 0% mortality as a goal is probably unrealistic as well. So if we're going in to try and put in fire with the hope of we can make sure every animal in that area survived the fire and is not negatively impacted at all, it's probably too lofty a goal to achieve. But there's certainly wiggle room, okay? There's certainly space for improvement, and that's what we're looking at over the next few years as part of the Wild Otways initiative. We're looking at whether or not we can improve this survival by producing patchier burn scars, or perhaps integrating some short-term and localized lethal control to try and take these predators out of the system preemptively so that they don't have a chance to respond to fire and exploit those burn areas at all.